Hello, welcome. Today we're going to talk about something that surely keeps you up at night. Were there colossal trees in the past? Don't worry, after watching this video, you'll be able to sleep peacefully. You may have seen a viral image a few months ago claiming that the Devil's Tower National Monument in the United States was not a mountain but the trunk of a giant tree that existed long ago. Some posts even claimed that scientists from the Wyoming State Parks Department discovered a massive, specified root system extending for several kilometers. As you can imagine, it was one of those Facebook memes that many people took seriously. The truth is, there has never been any statement from the Wyoming State Parks Department regarding this. It's all a deception. Well, that's another topic. But what is this formation really? At first glance, it does appear to be the trunk of a gigantic tree that was cut down. That might be the initial thought for someone seeing it for the first time. But as we always say, we should never be swayed by our senses. Our senses constantly deceive us, so what can we trust? We can trust the evidence left by science. For it to be a tree, or at least a plant, it would have to be composed of what plants are typically made of. If its composition doesn't resemble that of a plant or anything belonging to the plant kingdom, then we can confidently say it's not a plant, let alone a tree. A peculiar formation like this has undoubtedly caught the attention of scientists, and they would have wanted to examine it. And that's true, they have examined it several times, and the results are always the same. This colossus is made of a type of igneous rock called phonolite. What is phonolite composed of? Well, it consists of various minerals such as sodalite, lucite, titanite, magnetite, and several others that we won't mention to spare you from getting bored of the word titanite. The point is, that's what the analyses say. This formation is composed of these minerals. There is nothing that suggests to scientists that it could be or might have been a tree. Geologists agree that it originated from magma or molten rock buried beneath the Earth's surface. But there is still no consensus on the processes by which that magma cooled to form this type of tower. There is also no agreement on the relationship this formation has with the surrounding geology, but some hypotheses are being considered. The simplest explanation is that it is an intrusive body formed by magma that cooled underground, and part of it was exposed due to erosion. Another hypothesis suggests that the formation is an eroded remnant of a laccolith. A laccolith is a large mushroom-shaped mass of igneous rock that intrudes between layers of sedimentary rocks but does not reach the surface. This produces a rounded bulge in the sedimentary layers above the intrusion. This idea was quite popular in the early 20th century when numerous studies were conducted on various laccoliths in the southwestern United States. Another hypothesis suggests that it is the neck of an extinct volcano. The problem with this is that there isn't much evidence of volcanic activity in the area. There is no volcanic ash, lava flows, or volcanic debris that would make us confident that the tower was part of a volcanic system. Of course, there is also the possibility that such material has simply eroded and is no longer there. The last hypothesis suggests that the formation is the result of a mardiatreme volcano. This is a volcanic pipe that forms when magma encounters groundwater beneath the Earth's surface. The superheated water turns into steam, which expands explosively, creating a crater on the surface. The crater then fills with lava that cools and solidifies into a dome-like structure. Over time, erosion wears away parts of the dome to create the tower as we see it today. In reality, geology could be the most integrated of all sciences, as it involves the understanding and application of physics, chemistry, biology, mathematics, and even astronomy. So, if it's a science, then colossal trees of such immense size don't exist. However, there could have been giant trees in the past, at least larger than what we have today. It depends on what size we are talking about. There have been trees larger than those we have today that have surpassed them by hundreds of meters. The Cladoxylopsida is considered the first type of large tree to appear on Earth, or at least the closest thing to a tree that existed, as it was the first forest-forming organism on this planet. This happened almost 400 million years ago during the Devonian period. The question everyone must be asking is, how tall was the Cladoxylopsida? It measured between 8 and 12 meters. If you lived during the time of Cladoxylopsida and looked out on the horizon, the closest thing you would find to it would be today's palm trees with bases up to a meter in diameter. It had no leaves, only branch-like appendages that presumably had a photosynthetic function in the carbon dioxide-rich atmosphere of that time. How do scientists know the shape of this plant? Well, through fossils, of course. The oldest fossilized trees ever discovered date back to 386 million years ago and were found in an abandoned quarry in New York. Archaeopteryx and Cladoxylopsida were found there. As you can see, the oldest trees that we know of were less than 20 meters tall. The tallest tree known today is the coast redwood. reaching almost 116 meters, and no taller tree is known to exist or have existed. However, it could have existed. That's the other part, it depends. It could have existed, but only a few more meters. Two main opposing forces affect the height of a tree. One pushes it upward while the other holds it. Biologists from Northern Arizona University have analyzed this interaction in coastal redwoods, which are among the tallest trees, and calculated that the theoretical maximum height of a tree, or the point at which the opposing forces balance out and a tree stops growing, is between 122 and 130 meters. Researchers have found that trees in forests strive to grow as tall as possible to outcompete neighboring trees and reach more intense sunlight. On the other hand, gravity makes it increasingly difficult to transport water upward from the roots as the tree grows, and the leaves become smaller near the canopy. Scientists have also discovered that despite the moisture in the soil far below, the leaves in the tree canopy struggle to obtain enough water, leading to a constant drought-like condition. This lack of water reaching the top is another significant difficulty that affects and limits their growth. Other researchers have developed models for the maximum height of fir trees, which yield similar estimates of 109 to 138 meters. So, no towering trees the size of mountains. Don't be fooled. You know which organisms were monstrous compared to what we have today? Fungi. A few years ago, scientists identified through chemical analysis the Godzilla of fungi, a giant prehistoric fossil that had evaded classification for over a century. This fungus stood 6 meters tall, had a trunk resembling a tree, and went extinct over 350 million years ago. Can you imagine a 6-meter-tall fungus? It's fascinating, although we can't recreate the Smurfs world with it. Those years won't come back, and well, that's it for the video. If you liked it, subscribe.